Hi everyone, my name is Praveen Vanka and I'm a systems engineer here at Kasten. Today I'd like to show you how to protect a sample application like Postgres using K10. If you aren't already familiar, K10 is a data management platform for all Kubernetes workloads. Specifically, K10 is most commonly used for Kubernetes application data protection, such as backup and recovery, disaster recovery, and application mobility. By default, K10 provides crash-consistent backups via snapshots. For advanced and custom workflows, we have developed an open-source framework called Kanister. In this demo, I will use this framework to walk through steps required for a logical backup of Postgres using pgdump. More details about Kanister can be found in the docs here. Let's review my test environment to get started. I have a basic 3-node Kubernetes cluster with some applications installed, including K10. I have the K10 dashboard loaded, and here's what our landing page looks like. You'll notice that we've automatically discovered some applications running on this cluster, as well as their compliance status. When we look into the list of applications, we'll also notice that there's no Postgres installed. So the first step is obviously for us to go install the application, then configure it so that K10 can know how to protect and run the backups as we choose. What I'd like to do is I'd like to go back to our docs and look at the logical Postgres backup example, and we'll follow it. You'll notice it's only a few commands. It's actually pretty simple to not only get K10 up and running, but to install sample applications. So in this case, what we'd like to do is we'll go ahead and add the Bitnami Helm repo, because that's the chart that we'll use. We'll go ahead and add the repo, and to get the latest charts, we'll go ahead and run the update. Now that that's done, what we'd like to do is install Postgres in its own namespace. So we'll go ahead and create a sample namespace. Once that's created, we'll go ahead and run this command, ignoring the version because we want to get the latest chart. Now what we can do is we can watch for the workloads to come up, and once that's up, then we'll go to the next step. Let's just look at all. Notice a couple of services, stateful set and pods, or a single pod. So we just need to make sure that the workload and the pod is in a running state, which it is. Now that that's done, what we'd like to do is we'll go ahead and leverage a blueprint template. Now, we already have this pre-created, and I'll just quickly walk us through what this looks like. So Blueprint is nothing but a Kubernetes custom resource. And as you can kind of tell, right, there's name associated to this blueprint and some actions. Specifically, there's a backup action, restore action, and a delete action. In backup action, as you can imagine, there are different phases. So you can actually define things to happen in a pre-backup phase. For example, something like quiescing a database or freezing and then flushing data to disk, etc. Right? Whatever is required for you in your environment, you can go ahead and define those. Likewise, in the arguments, you define connection information using config map, secrets, any sensitive information that you need, as well as the tool that's required to backup this this application. Again, I mentioned we're going to use pgdump, so we're going to run with that command. And then on the restore, you get to define what needs to happen. You can also do other things like sanity checks or validation of datasets after restore with post-restore phase. This, if you look at this blueprint closely, you'll notice that it's pretty basic. All we're saying is, hey, go take, use this login information, talk to my database, and go ahead and put it to an S3 location. So what we'll do is we'll go back to the docs to create this blueprint. And blueprints are always created in the Kasten namespace because K10 needs to know what actions to run. And then by default, K10 uses the storage provisioner and storage class to take snapshots. But in this case, we're going to annotate the stateful set for Postgres to let K10 know to use the blueprint instead. So once that is annotated, we'll come back to the K10 dashboard. And you'll notice that Postgres showed up here, right? And so what we'll do is we'll go ahead and create a policy to protect this application. Now, when you do that, some information is pre-filled. So we'll just quickly scan through this. Name, you can choose whatever name you want for this policy. There are only 2 action types. Because we want to protect, we'll leave it at snapshot. Likewise, there's an action frequency that you can select, as well as sub-hourly options. And retention schedule, right, to tell you how many snapshots you want to keep. Every policy gets to protect a set of applications or a single application, and you can protect multi-app policies using labels, either existing or custom ones, or by name. In my example, because we only want to protect one application, we'll go ahead and select it by name. You can also use wildcard searches if you have a naming convention that you follow. Of the resources that are part of this application, you get to filter them in or out. Our recommendation is to back everything up, and then you can always filter and restore. Because we're invoking a Kanister action, we will go ahead and choose a profile here. Keep in mind, K10 can support and take advantage of any S3 compliant storage target as well as NFS targets. I have a couple of options here. I'll just choose something at random and go ahead and create this policy. Now, we'll go ahead and run this once to kick off an on-demand job. And we'll go back to the dashboard to watch for activity. You'll notice that we've immediately started protecting the workloads, configs, and what we're doing at the last step is protecting the data on the PVCs. Okay, that's done. We can go ahead and click in to get a list of items that were captured. You'll see that PVC that was captured as well as the specs that are part of this namespace. Now what we want to do is we want to test that we indeed protected this application properly. So one of the very quick tests, again, that you can do is we'll come back here to the application, and there you'll notice there's a restore point. We'll go ahead and select it to restore from. You can either override resources in the existing namespace, or for the purpose of this demo, I will go ahead and bring it to restore test namespace. So we'll go ahead and create it, and what I'd like to do is I'd like to bring everything back. I'll go ahead and restore this into a new namespace. My expectation is that the application, which was backed up successfully, should also be restored into a fully working state. Okay, now that this is in a solid green state, we know that the restore job has been completed. And when we scroll up, you'll notice there's 10 applications. can also come back to the command line just to verify that we have resources running in this new namespace. So PostgreSQL all, restore test, get all. There you go.